Hello, great people. Welcome back, and I'm Riraiden. So today we are going to talk about chromatography, and basically we have two types of chromatography. We have the basic chromatography and instrumental chromatography. So for basic chromatography, it has three types, and this is paper chromatography. We have the TLC, we have the column chromatography. So basic chromatography is the chromatography that is basic. It is, so we can take example of the paper chromatography. You just observe with your eyes. So for instrumental chromatography, it has two types, and this is high performance liquid chromatography, that is HPLC, and we have the gas liquid chromatography, that is the GC. So basically today we are going to talk about gas liquid chromatography, a type of instrumental chromatography. Welcome. So first we're going to define it, and we say gas chromatography is a common type of chromatography used in analytical chemistry for separating and analyzing compounds that can be vaporized without decomposition. That is the definition of the GC. So typical uses of the GC are two, and the first one being testing the purity of a particular substance. So it is used to test the purity of a particular substance if it is pure or not pure. So the second one, it is used to separate the different components of a mixture. So maybe if we have a sample that contains two or more mixtures, so GC is used to separate the different components in that mixture. That is our introduction part. So GC has its components, and these are the carrier gas. And for the carrier gas, helium is the common carrier gas used in the GC. So it is used because of its excellent thermal conductivity. It is thermally stable. It is inert in nature. It has the lower density, but again it has a disadvantage of being very expensive. It is too expensive. So perhaps hydrogen can be used, and it can be used because it is thermally stable, it has a lower density, and it has a disadvantage of reacting with unsaturated compounds. Thus it creates a fire hazard. So hydrogen can be used, but not in most cases. And maybe sometimes oxygen can be used. So but helium is being the most preferred carrier gas. So GC has carrier gas, it has the flow controller, it has the injector, it has the column and oven, or rather column oven, it has the recorder, it has the detector. So that is the components of the GC. We have the schematic diagram of the GC. And we can see the carrier gas. We said helium most being preferred because it is thermally stable, it is inert in nature, it has the lower density. So we have the flow controller. This controls the flow of the carrier gas. It controls the flow of the carrier gas. We have the injector port where the sample is being injected through. We have the column. For column, we have three types of column. We have the three types of column. We have the packed column, we have the open tubular column, then we have support coated tubular column. So we have three types of the column. So but packed column is most preferred. Yeah, so you can see the column oven where the temperature is being controlled. We have the detector, we have the recorder stroke the output. That's our schematic diagram. Injection of a sample in the GC. And this explains how sample is injected into the GC. So bearing in mind that we have two different sample injection system. We have the split and splitless injection system. So for split injection system, it is the most common injection system where after a sample is injected, then a portion or a ratio of the injected sample goes to the column. This is common especially when the sample is concentrated. So it is used when the sample is concentrated. So it is the common injection system. But for this GC, we'll be using the split injection. Here. For splitless injection, it is used to trace analysis or analyze the dilute compounds. So splitless injection, it is used to analyze the dilute compounds. So the difference is that for the split injection, the sample is concentrated. For the splitless injection, the sample is diluted. Yeah, so injection of the sample in the GC is that very small quantities of a sample that you are trying to analyze or injected into the machine using very small quantities of a sample that you are trying to analyze are injected into the machine using the small syringe. The syringe needle passes through a thick rubber disc known as septum, which reseals itself again when the syringe is pulled out. So the injector is contained in an oven whose temperature can be controlled. So the temperature can be controlled in an oven. So it is hot enough so that all the sample boils and is carried into the column as a gas by the helium or other carrier gas. We said hydrogen and in some cases oxygen. So that is how injection of a samples works in the GC. So we're going to discuss about how separation in the columns works. So how does separation of the injecting a sample into the GC works? So one of the three things might happen to a particular molecule in the mixture injected in the column. So the first one being it may condense on the stationary phase. The second one, it may dissolve in the liquid on the surface of the stationary phase. And then the last one, it may remain in the gas phase. None of the three things is necessarily permanent. None of the three things it ain't permanent, all of the three things. So a compound with a boiling point higher than the temperature of the column will obviously tend to condense at the start of the column. However, some of it will evaporate again in the same way that water evaporates on a warm day. Even though the temperature is well below 100 degrees, the chances are that it will condense again a little further along the column. So similarly, most molecules may dissolve in the liquid stationary phase. Some compounds will be more soluble in the liquid than others. The more soluble ones will spend more of their time absorbed into the stationary phase. The less soluble ones will spend more of their time in the gas phase. So the process where the substance divides itself between the two immiscible solvents, because it is more soluble in one than the other, is known as the partition. That is the definition of the partition. So we can say that the substances partition itself between the stationary phase and the mobile gas phase. So any molecule in the substance spends some of its time dissolved in the liquid and some of its time carried with the gas. And that is how separation in the columns works. So we have the principle of the GC. How does the GC works? And GC is based upon partitioning of the compounds between the stationary liquid and mobile gas phase. And due to its high sensitivity and speed of resolution, it is widely used for several qualitative and quantitative analysis. So for qualitative analysis, it is the analysis which you can see with your eyes. I mean, you can observe. So for quantitative analysis, quantitative analysis, it is the one which you can measure and calculate at some point. Yeah, that is the difference. So the principle of the GC is that the gaseous compounds being analyzed interact with the walls of the column which is coated with different kinds of stationary phases which causes each compounds to elute at different time. This is what we call the retention time. And then retention times are compared, which makes GC analytically very useful. As compound leaves the column, they pass through a detector, which is linked to the chart recorder by the amplifier. Chart recorder records the peaks, and that is the output. It shows the results of what we are trying to analyze. We have the application of the GC. Basically, GC has many applications. It has many applications, but for our case, we're going to discuss about the 3 applications of the GC. So, gas liquid chromatography has a very wide field of application in the separation and analysis of the multi-component mixtures such as essential oils, hydrocarbons, and solvents. It is one of the primary analytical techniques which was used in forensic laboratory. So, our first application is that GC combined with the mass spectroscopy for drug detection, fire investigation, for environmental analysis, for explosives investigation, and identification of unknown samples. So that is the first application of the GC. So GC, the second application is that GC is used in airport security to detect unwanted substances. So it is used in airport security. So non-derivatized sugars and sugar alcohols are successfully analyzed by the GC using atmospheric pressure chemical ionization, APCI in short, in negative ion mode. So GC analyzed non-derivatized sugars and sugar alcohols using atmospheric pressure chemical ionization. So the last application is that GC is widely used by forensic scientists for analysis of the body fluids for the presence of the illegal substances. So it is used by forensic scientists for analysis of the body fluids, e.g. the sweat, the urine. Yeah, it is used to analyze the body fluids for the presence of the illegal substances, testing of the fiber and blood from the crime scene, and to detect residue from the explosive. That is the end of our discussion. Thank you for your time.